What is CO2 injection? An oil-producing reservoir will go through many phases of production during its life. Initially, the pressure within the reservoir is high enough to let the hydrocarbons flow out freely. When this pressure drops, secondary recovery methods are applied. And lastly, there are enhanced oil recovery methods used to extract the remaining hydrocarbons. The flow from the reservoir isn't pure oil and often contains many gases. Perhaps you have seen the flames from the top of smokestacks at oil refineries or at drilling sites. We typically flare off, which means to burn, the gases that come from the reservoir as well as the gas evolved when refining. This is where CO2 injection comes into play. Instead of flaring off the gas, we now capture the carbon dioxide from the well, and sometimes from the refineries, and inject it back into the reservoir to enhance the flow rate and recover even more oil than before. A typical injection process looks like this. Starting on the left, we have the injection well that alternates injections of carbon dioxide and water. These injections permeate the reservoir and mix with the unrecovered oil. This causes swelling and increased pressure, which frees the oil from the rock and enables it to flow to the production well to the right. We had planned on visually representing the technique with a 3D printed model demonstration, but had to scrap the idea after our plastic models went on hold. So instead, we crafted one. This is our crafted reservoir. The blocks of foam represent the Earth's crust, and coincidentally, the bottle of soda that represents our reservoir does an outstanding job as it is a single-phase mixture of more than one component, just like a real reservoir. Complete with a standing rig centered above the reservoir and 2 injection sites, the visual representation of a gas injection process is quite clear. The straw here represents how the injection well site is different from the location of a production well. There are usually multiple injection wells involved when flooding a reservoir with gas. The gas will be injected into the bottom of the reservoir and force the unproduced hydrocarbons into the flow stream of the production well. Now for the demonstration. Here we see how the soda bottle represents a reservoir. There is liquid and a considerable amount of gas. As stated earlier, primary recovery is when the reservoir is untapped and all that is required for hydrocarbons to flow is drilling a well. The initial well is demonstrated here by puncturing the cap of the soda bottle, releasing the pressure. And as you can see, the flow is quite rapid, but dies out rather quickly. Notice how foamy the soda, which represents our oil, is as it flows out of the bottle, which is our reservoir. This indicates a large percentage of gas. In the field and at refineries, as stated before, we burn off this gas. That seems like a waste, doesn't it? This is the beauty of using carbon dioxide injection as an enhanced recovery method. Instead of wasting something that is already there, we use it to its full potential. Take a look at our reservoir. Due to the natural flow of primary production, only about 15% of our oil has left the reservoir. This is consistent with real-life production because according to energy.gov, the average amount of oil extracted from primary production is only 10% of the oil actually in place. After secondary recovery, anywhere from 20 to 40% of the oil is produced. But with using the enhanced recovery method of CO2 injection, as much as 60% or more of the oil can be recovered. You may be thinking that this technology sounds too good to be true. In our other videos, we will be exploring the geopolitical aspects, the economics, as well as the technical feasibility of the fastest expanding enhanced recovery method in the United States of America.